We're going to go to Desmos. We're going to look at how to graph this. F of x equals parentheses x plus 3 squared. And then if you remember from the video, you've seen how to type this in Desmos. How do we get the table very quickly? You didn't watch my video. There's a faster way. Go to the gear. When I say settings, my mind thinks this. But by the way, there is a lot you can change over here if you ever wanted to. Anyways, the gear. And then click table. Now, it's always going to default beginning at -2. You can come down here to the bottom and you can type additional values if you need to know any additional ones. So let's look at our sheet. Like we need -6, -5, -4, -3. So I'm going to go over here and I'm going to type -6, -5, no, -5, -4, -3. And then I can copy those values to my worksheet. Okay? Just a real quick reminder. This is a function, so the way it's getting those values is it's taking these x values and plugging it in right here where you see x, and then evaluating it, and that's where the y value comes from. And then we're going to copy it to this graph right here. And then it does say, what's the difference between f of x equals x squared and this one? So let's graph on here an additional f of x. Now, if you do that, watch what happens. The table disappears. You know why? There's 2 f's. So if you really wanted to leave both on there, just change it to another letter. Okay? I'm also going to make it dotted just so that y'all can see. There we go. So I can see the table. I can see the graph. I need to copy it to my paper. So someone read to me the y value for -6.
9, 4, 1, 0, 1, 4, 9.
Now, notice the symmetry in the table. I can see right here that -3, 0 is the what?
Okay.
It's the vertex. This one's the vertex. Because I can see the symmetry in the y values on the table. So there's our axis of symmetry right there. So this is going to be reflected over. Now the questions say, what's the domain, the range, and the vertex? We already found the vertex. What's the domain? The domain should never change, guys, for quadratics. What about the range?
0.
So it's nothing, nothing, nothing. Then you have something here at, what's the y value? 0, and then it goes to
Negative, or infinity.
to infinity. So it's 0 to infinity. It says, what's the difference between this graph and the mother function? That's where Desmos is helpful. Go back to Desmos. The mother function is the dotted one. This graph is the red one. What happened? It moved what direction and how many spaces? It went left 3. Left 3. So what's the difference between these? You would say this is called a horizontal shift or translate horizontally left 3. It translated or shifted. You need to know both words. Left 3. Now, if you were to just guess, what would you say the second one did? Look at the second equation. Look at this one. Now remember, down is when it's that number on the very end. Remember the sheet from last Friday? We said that any number on the very end is literally go up or come down, right? But this one's not at the very end. Where's this number? In the parentheses. So this one went left 3. What? How many? You think it's going to go right 5? Put it in Desmos. Put it in Desmos and see. Can someone tell me the table? It's only going from 2 to 8. So I can see that's the vertex. I see its symmetry. All right. What's the domain? It is all real numbers, negative infinity to positive infinity. What's the range? 0 to infinity. Bracket on the 0. Even though it's shifted right, it's still starting at 0. Are you with me? Yes. Okay. Get off YouTube. What's the difference between the mother function and this one? You already said it. What's it doing?
Shifted right.
It's going, and I want you to know both words because I don't know what the state's going to use. Translated or shifted. I think they're going to use the word translated. Right 5 units. I want you to think of translators. They take what you want to say and shift it, slide it into another language, right? So it's the same thing you said, but it's in a different language. So it's the same graph, it's the mother function, it's just shifting over right or left. Or translating also can go up or down. But it's the same curve, it's just literally picking that up and moving it, right? Go to the back. Now we're looking at something that changes, or a different type of change. What's different here from our mother function? What's different? Like, here's the mother function. Where's the 2?
In front of it.
In the very front. Do you remember what variable that represents in standard form?
A.
What?
A.
Yeah. When in doubt, standard form, A is the beginning of the alphabet. A Alphabetical order is the standard way to organize stuff. A is your leading term, leading coefficient. You'll notice that A is 2 here. Go to Desmos and type it in and see what happens. Go to Desmos, type it in. Let's use a different word. It did get skinny, which is probably why you thought shrink, right? But I don't want you to think shrink because it's actually a stretch. What happens when you stretch? Right? Don't you get, like, your body is normally, this much space, but when you're stretching, obviously, you take up less room because you're stretching, right? Okay, this is a vertical stretch by a factor of 2. It's a vertical stretch by a factor of 2. It's taking all of the x values and it's multiplying it by 2. So instead of 1, 4, 9, we see 2, 8, 18. Because everything got multiplied by 2. So it still sits right here on the origin, but now it's 1, 2, 2, 3, 4, 5, 6, 7, 8. I can't even graph the next one. Right? Now, if you need to, you could put the mother function on here in a dotted line, in dotted format. Let's see. Is that right? No, that's too far. You can see the mother function compared to that one. This one's skinnier, right? What's the domain? Why are y'all not answering before I read it? What's the domain? Negative infinity to infinity. What's the range? 0 to infinity. The vertex? 0, 0. So what's the difference here? It is a vertical, this is the fancy word for it, stretch by a factor of 2. Vertical stretch by a factor of 2. Now, if this was a vertical stretch, what do you think this one's going to do?
Vertically compressed.
All right, hold on. If the vertical stretch is what we just, oh, I see what you're saying, compress. All right, that's fine. Or you could say shrink. Compress, shrink, that works. So this one's going to be a vertical shrink. Will you please put it in your computer in Desmos and look at it? finish the 4. You're at 1. Because there should be symmetry to it, right? Alright, so the vertex is 0, 0. We already know the range. I mean the domain, sorry. Here's our vertex, right there in the middle. So to graph this, you're just going to do the best you can with the halves. Just go halfway. So we got 0, 0. Then right 1, up a half. Right 2, up 2. Right 3, up 4 and a half. And now I'm going to mirror image that. Now, if you graphed the mother function on the same graph on Desmos, you'll be able to compare where it is wider, right? What's your range? To infinity? And beyond?
LOL.
This is the mother function. This is the one we just graphed. It is a vertical shrink by factor, what do you think, of what? What's the factor it's shrinking by? 1/2. Now, this piece of paper has just taught you the last 2 transformations that we're going to work with. The one on the front was when it's shifting right or left. The one on the back is when it's stretching or shrinking. Now, the shrinking, the stretch and shrink, that's the hardest one for people to remember. Yeah, this will work. Usually I use a rubber band, but I don't really have I'm not allowed rubber bands. So we're going to pretend like this is a rubber band. Y'all with me? My lady. This visual is what my my geometry teacher, actually no, she was terrible. This is what my pre-calculus teacher did, and I remembered it, and it helped me. So I'm going to do it for you too. Pretend it's a rubber band though. Work with me here. You with me, Hampton? So the mother function, okay? You got to ignore this up here at the top. Imagine a curve. You with me? Imagine a parabola. So ignore. I can't. I was going to say I could do it, but then now it's a V. So work with me. I'll cover it. There we go. All right. Here's the mother function. You with me? You see how it's just a normal curve? Everybody with me? Okay. A vertical stretch by a factor of 2 is like doing this. Do you see how I pulled my arms apart and it gave this image of now we have a tighter curve, I guess you could say. You see the stretch?
Oh, that's really small.
Okay. I'm actually Thank you so much. You're awesome. I still have a few more minutes. You're awesome because his appointment's at 10:20, so that's great. All right, lock back in with me. Here we go. So here it was in mother function mode, right? Regular. And then we put a 2 in the very front of it. So now it's stripped. Fun fact, this is a breakaway lanyard, so the kid can't choke me. Now I know it works, right? It just fell apart. I'll try to hold it together. Okay, back to the mother function. Here's the normal. I'll try to make it a little bit more. So, all right, here comes times 2. You see what happens? Gets skinnier because it's stretching. Imagine that rubber band stretching. Now we're going to stick a 1/2 in front of it. So let's go back to the mother function. And now we got a 1/2. I want you to visualize the floor and the ceiling collapsing. Now this is really hard for me to do all at the same time. But if you visualize a floor and a ceiling, imagine this is sitting from the floor to the ceiling, and it's the mother function. And now the floor and the ceiling are going to collapse. What's this curve going to do? It's going to get very wide, almost like one of those big old giant bowls, right? like the big old salad bowls that they bring to the table. That is a vertical shrink. So as the room is shrinking, imagine a curve that no longer has room because it's shrinking. So it's just going to expand out. You with me? So that's why this did this. So vertical stretch, lots of energy, big numbers, lots of energy to do this. How much energy does it take to shrink the room? Not much. All I got to do is relax my hands, right? And the curve starts compressing and going out. So, small number, 1/2. Big number, stretch. Think big stretch in the morning, right? You know you got told that when you were a toddler because it looks cute when toddlers stretch or babies stretch. And then little number, it's shrinking. Little energy. It does not take a lot of energy for me to bring my hands together, and this curve is just going to start falling apart. Why? Does that visual kind of ring a bell? Now let's come right here because this is where we sum it up. Remember on that last paper I said the bottom of this is the most important part? This is the most important part. All right. So right here, this is x plus 3. We said that makes the graph do what? Do what? Move to the left 3. And when it was x minus 5, we said that makes the graph move which way? Right 5. When it has a 2 in the front, we said it makes the graph do what? Stretch, vertical stretch. When it has a 1/2 in the front, we said it makes the graph. My arms are getting closer together. The room is shrinking. The space is shrinking. So it's a vertical shrink. All right, here's what I want you to do. So we're going to write it down. This was translate left. This was translate right. This is a vertical stretch. This is a vertical shrink. You're good, you're good. Sorry.